Welcome back to Business Mathematics. We are still in Chapter 3, Ratio and Proportion. This lesson is about inverse proportion. Two quantities, x and y, are inversely proportional if a change in one variable causes a proportionate change in the other in the opposite direction. The analogy that teachers often use to describe inverse proportion is the analogy about the seesaw. So if this part of your seesaw goes down, the other part or the other end of your seesaw goes up. If this part goes down, then the other end of your seesaw will go up. In symbols, this is how you write it. Y is inversely proportional to x. Okay? So when it is written as 1 over x, that is how you read it. Y is inversely proportional to x. But you can also read it in this way. Y is directly proportional to 1 over x. It is also equivalent to saying that y is equal to k over x, where k is a positive constant. These are some examples. Time to finish a job and the number of workers working on that job. So the time to finish a job is shorter when you have more workers working on the job. Okay? So again, let us read this. T is directly proportional to 1 over n. Another way of reading it is in this way. T is inversely proportional to n. It is equivalent to saying that T, the time to finish a job, is equal to k over n, where n is the number of workers and k is your constant of inverse proportion. Another example which you heard about from your science subject is the relationship between the force of attraction between two masses and the square of the distance between them. Okay? This was introduced to you by Sir Isaac Newton. Or another way of saying it is the force of attraction between two masses is directly proportional to 1 over r squared, where r is the distance between the two masses. And that is written in equation form in this way. The force of attraction is equal to G sub k. G sub k is your constant, the gravitational constant. So the force of attraction between two masses is equal to G sub k times the product of the two masses divided by the square of the distance between the two masses. So the constant of inverse proportionality is given by this, G sub k. Workers at Julie's Bake Shop need 3.5 hours to finish the pastries that have to be sold each day. How many hours would it take 15 workers to finish the same job? Find the value of the coefficient of inverse proportionality and write the equation. So this one is of course a simplification of what is taking place in an actual bake shop. Okay, so which is why we have to make the following assumption. The assumptions are the bake shop has an ample space to accommodate the additional workers, and of course, the bake shop has enough tools for the additional workers. So if we shall keep these assumptions in mind, this is an example of inverse proportion. This is a problem about inverse proportion because our intuition is telling us that the more workers we have working on a particular job, the quicker is the time needed to finish it. When you say it is quicker to finish the job, that means the time needed to finish the job becomes shortened. Okay? Let us set up the equation. Since this is one about inverse proportionality, y is equal to k over x. X is the number of workers working on the job, and y is the time needed to finish that job. This also means that k is equal to y times x. K is the constant of inverse proportionality. Since k is constant, okay, 3.5 times 12, okay, it came from this. If you have 12 workers working on a particular job, they need 3.5 hours to finish the job. And their product is constant. That is your constant. It is also equal to this. Y times 15. 15 is the number of workers who are now working on the job, and y is the time needed for 15 workers to finish the same job. And so these two must be equal. This constant is also equal to y times 15. Solve for y. Y is equal to 3.5 times 12 divided by 15. It is equal to 2.8 hours. The value of k is equal to 3.5 times 12, which is equal to 42. And then write the equation. The equation is y is equal to k over x. Y is equal to 42 over x.